And we're live. Welcome to the review session. Here we go. Okay, we got 45 minutes roughly to get this done. It ain't gonna happen. What I would suggest is you take pictures of this if you want to see it. I also have other copies that I have not fully, but mostly filled out because I did 3 of these yesterday from noon to 9. I want to die. So I would take a picture. I'm just going to talk as I go along. That way I don't have to write stuff as I go. You shouldn't have to either. And wait till I give you the full shot, because right now it's small. So here's the concept for the first one. We want to prove that AB is 15. Okay? So here's how I'm going to do it. Notice the purple and the blue I added, so we don't know what those lengths are. Okay? So what I'm going to say is that, look, BD, the red segment, consists of the green and the blue. So I write that. BD is green and blue put together by segment addition postulate, right? The 2 small segments add up to the big one. Then I'm going to plug those values in by substitution. So I plug those values in. Then I solve and find that CD is negative x minus 5. So I write that. That's the first bit. Second bit's the same thing. I'm just doing it for the other side. Orange is purple and green put together. So I write that by segment addition postulate. Then I substitute their values. Again, I don't know x plus 10 yet, but I'm going to find it. I plug that in. AB I don't know, so I leave it AB. And I solve and get AB is x plus 10. And I write it up here. Then I'm going to say these 3 segments put together should get me the Pank segment. So purple plus green plus blue is going to get me Pank. And I wrote that. That's by SAP, segment addition postulate. Then I substitute their values. X plus 10, 6, and negative x minus 5 equals 3x minus 4. Then I do math, and I find that x is 5. Now I'm going to take x is 5, and I'm going to plug it in here to find out what AB is. So I say AB is x plus 10. I found that out earlier, so I can just write that. And then I plug in 5 by substitution and find out AB is 15. How do you feel? Okay. Again, the idea was figure out the first bit, right? Do the same thing for the second bit, and then put them together, find x, and then plug it back in. You'll need angle addition postulate and substitution to solve this one. How you feel? D's? I'll take D's. No, they're not. They got pizza grease all over them. Unfortunately. So that's that on that. I'll zoom out so you can take a picture if you want. Haha. Do better for the environment. I can't do better for the environment. I've done all that I can. Time to reload.
Curry range.
Are we good on this one? All right. These are more examples, so try those on your own. I'm going to skip them. Here we are, page 4, number 4. It looks like a lot, but it's really not if you know what it means. Let me show you what it means. So the idea is we're going to take this triangle, and to find the distance between the 2 points, we're going to break it up into vertical and horizontal distance, right? Trying to find the distance there is too difficult. So we break it up into its vertical and horizontal parts, right? We're traveling a little bit down and a little bit over. So we break it up into those 2 bits. I'm going to put a coordinate plane down here and find out how long A and B are. I'm going to write how long A and B are. And then I'm going to plug them into Pfag. Hello.
I am not kidding when I say that it won't let me print it.
Okay, that happens. Get it to me before tomorrow's class. That's it. So, label your coordinates. First thing, I drew a coordinate plane to help me out. So that's x1, y1 right here. So that's the coordinate right there. And then this is going to be x2, y1 here. Are we cool on that?
Do we have to include all the points and stuff like that? Like x1, y1, and all that?
Yes. x1, y1, because it's the first x and the first y. x2 is x2, y1. And this one's x1, y2. Are we cool about how to find the points? I think a lot of people get stuck on that. Okay, I drew myself a coordinate plane. See how these are x's because they're on the x-axis? That's the first x, and that's the first y. So that's x1, y1. Then that's the next x, so it's x2, y1. Getting it? Yeah! And then that's x1, y2 here. Much better? Okay, cool. So then we need to figure out how long A and B are. Well, remember, distance is subtraction. And the reason for that is, imagine we want to know how long B is. Well, if we looked at these coordinates, pretend that was a 10 and that was a 2. How much space is between them? 8. And you figure that out by subtraction. So x2 minus x1 is how long it is. You tell me what they are, and I'll be able to tell you how long it is. But until then, we'll keep it algebraic. x2 minus x1. A is the vertical distance. So it's just going to be y2 minus y1, however much space is between here, right? So I write that down. Vertical distance, because subtraction is distance, and y is vertical. Horizontal distance, because subtraction is distance, and x is horizontal. And of course it's horizontal distance. Look at the segment. It's horizontal. That's vertical. Now that I know what a and b are, I'm going to plug them into Pythag. Pythag is a squared plus b squared equals c squared. So instead of writing a, I'll write what a is. y2 minus y1. Yes, a is the vertical part here, so you need to write y's first on this diagram, not x's. Will it change the math? No, but it changes the proof. B is x2 minus x1, so I plugged them in. Don't forget to square them, right? Still Pythag. And then I root, and I get distance formula. That's where distance formula comes from. It's the horizontal distance and the vertical distance squared, added, and rooted, and that gets you the total distance. Yeah. It's just taking this weird distance and breaking it down into easier distances and plugging it into Pythag. That's it. That's vertical distance. That's the horizontal distance. Put them together, and you get the overall distance, which is a little bit horizontal, a little bit vertical, right? It's diagonal. How do you feel about that one? I did. And I fell asleep watching the first review from yesterday because it was supposed to be funny, and then the first hour I forgot was so boring.
You were just waiting for it.
Well, I've already taught that stuff 3 times yesterday, so yeah, I did get bored of it. I watched the first one because the first one's the funniest. The last 2 hours of it are great. All right, so this one. 2 things they want you to do. Distance formula, and then divide the segment up by this ratio. Well, that ratio means we have 1 piece on one side and 1 piece on the other. So we divide it into 2 even pieces. So we're cutting it in half, right? It doesn't matter if we cut into 2 and 2, right? I am not a crook. It'll be the midpoint either way, right? If it's the same amount on each side, it's the midpoint. So we're going to use midpoint formula to divide it up. Midpoint formula is average of the x's, average of the y's. When we average stuff, we add and divide by the number of pieces. So x1 and y1 come from a because we're starting on a. And then b is x2 and y2 because we're moving towards b. So we're going from a to b here. So I put in x2 first. That's important. It doesn't matter for this problem, but it will matter in a later problem, so just get used to it. x2 comes first, and then x1. Then y2 and y1. We're averaging our 2 x's. We're averaging our 2 y's. When we put them together, we get 1 and 5, which is 6, divided by 2, which is 3. Here you get negative 4 divided by 2, which is negative 2. So the midpoint's going to be at 3, negative 2. Right there. And if you put A and B on there, look, it is in the middle. Yay! You divided it evenly in a 1-to-1 ratio. You did it! Then, we need to find the distance. Well, you could do distance formula and plug in your coordinates. Remember, what does this stand for? Horizontal distance. What does this stand for? Vertical distance. Well, I know the horizontal and vertical distance. It's right there, you dingus. It's 4 and 10. So instead of doing all the math, I could just plug it into Pythag and do it. Right? Or I could do all the math and make sure I don't screw it up, and you'd still get 4 and 10, because that's how far they are apart. The negatives cancel when you square them, right? And you get the same answer. So it's up to you which one you want to use. I would do this one if I have a picture to look at. And if I don't, and I just have to plug in points, well, then use this guy, right? Your choice. Questions on that one? We're not going to get through the whole thing anyway, so we might as well take our time. Yes. This side. Yep. Midpoint formula. You know what that is? Average of the x's, average of the y's. x2 comes first, and then x1. y2, y1. Add them up, divide by 2. That's the midpoint. That's right. Okay. What if the ratio isn't 1-to-1? What if they say, hey, I want to not go halfway. I want to go 3/8 of the way. Well, 3/8 of the way is dividing up the distance between A and B into 8 pieces, and A is going to be 3/8 of the way, right? Which means 5 left over for B. So on one side there'll be 3, on the other side there'll be 5, which means our ratio is 3 to 5, not 1-to-1, right? So we're going to use 3 and 5 here. Now, before we did use 1 and 1, we had 1-to-1. We used it here next to the x's and next to the y's. You just didn't write it because 1 times x2 is just x2, right? Yeah, it's unnecessary. The midpoint formula is just a very specific version of the section formula. It's where you're dividing it perfectly in half. The section formula lets you do any ratio, and we want 3 to 5. Remember, x2 comes first, y2 comes first. That's super important because we're starting on A and walking towards B. If we started on B and went 3/8 of the way, we'd end up here, which would be a different point, right? So make sure you write x2 and y2 first. If you flip those, then you're going to get the point that's closer to B, not closer to A. So 3 and 5 go here because that's our ratio. Does everybody see how I got my ratio? 3/8 of the way means 3 out of 8 total pieces. 5 left over. So 3 to 5 is the ratio. So I plug in 3 and 5 for a total of 8 pieces. We're still averaging here, right? We have 3 of these guys, 5 of those guys for a total of 8. We're adding. X2 and Y2 come first. We plug in our coordinates. Trust me on this. You get negative 32 and negative 8 when you do all the math. You divide by 8 and you get negative 4 and negative 1, which means that point will be 3/8 of the way between A and B, which it is. Now, if you flipped your X and Y, or your X2 and X1 and your Y2 and Y1, you would have got the point that's 3/8 of the way between B and A. Starting on B going to A, you would have gotten this point. Okay? So no bueno. Make sure you do X2 and Y2 first. X2 and Y2 are from here, because that's your destination, right? How do you feel? Do we need time to digest for a second?
Nope, no regrets.
Feeling good? No regrets. That's right.
He knows what's up.
Is that the sound of someone's brain exploding? Okay.
Yeah, if it's out of my chromosome, shine
All right.
like they can.
Distance formula aside, ratio is 1 to 1. So what formula do we use?
Midpoint.
Midpoint, right? It's 1 to 1 halfway, right?
Yes, sir.
For this one, what would our ratio be? The fraction is 2/7, so we want a point that's 2/7 of the way. 2 to 5. 2 on one side, 5 on the other for a total of 7. The way you set it up is 2 and 5. X2 comes first, and you divide by 7. Same thing for your Y's. How do you feel? Distance formula, plug them in, or do the thing, right? What?
Why don't you put the X, like the actual X2 value over here?
I was showing the formula, and then we plug it in. I don't know. Less work. Next, brace yourself. Okay, this one. Everybody hates this one, but it's really not bad. Midpoint, we know. It's this formula. Average of the X is average of the Y's. Now, normally, we take our two endpoints, and we plug them in here, and it gets us our midpoint, right? A and B, we plug them in, our two endpoints, and we get the midpoint. Well, this time, they've told us the midpoint, and have told us the endpoint, but we don't know the second endpoint. That's the one we're finding. So normally, we plug in our endpoint here and here for the second endpoint. So I'm only going to plug in this endpoint for X1 and Y1. And I'm going to plug in the midpoint where the midpoint is. A lot of you guys want to plug the midpoint in here. That's what M means. That's the midpoint. The M means midpoint. So you're going to plug it in there. So M is the midpoint. I plugged it in. I plugged in for X1 and Y1. I left X2 and Y2 alone because that's the point I'm looking for. Are we cool with that setup so far? You with us, Tana? Yeah? Okay, just want to make sure. If not, tell me. Katie? David? Good. So now I know this equals 1, because normally we do all our math and it gets us the x coordinate, right? So I'm going to do my math. I know that x2 minus 3 over 2 should equal 1, so I wrote that. How do I get x on its own? Times 2. That makes 2 on this side. Add 3. Now it's 5. We good with that? Next part, I know this should equal 5 halves, so I write that. Y2 minus 2 over 2 equals 5 halves. I times by 2 to get rid of the division. That's 5 halves times 2 on this side. What's 5 halves times 2? 5. Because 2 divided by 2 is 1 times 5 is 5. Or you could have done it this way. 5 times 2 is 10 divided by 2 is 5. Again, times by the top, divide by the bottom. Your choice. Just got to do both. So we get 5, and then we have to add the 2, and we get 7. So 5, 7 is the halfway, or not the halfway point, the end point that we were missing. Questions on that idea?
No, sir.
Maybe it'll blow your mind. I still need to see all this work, but here's something that might make more sense. Notice the end point starts at negative 3 for x, and then it ends up going halfway to 1. So after we've traveled halfway, how much have we traveled? Negative 3 to 1 is 4, right? So if we traveled 4 halfway, should we travel 4 again to find the other bit? What's 1 plus 4?
4.
Ooh. This one's harder because there's a fraction. We're going from negative 2 to 5 halves in the y direction, right? So we went up 4.5. Trust me on that. That's 2.5. If we add 4.5 again, nope, if we'd add 4.5 again, we get 2.5 plus 4.5, which is 7. Do I need to see all this work? Oh, yeah. But could you check your work with that? Yes, you could.
Oh, yeah.
Can you take a picture or no? Sydney! Need to take a picture or no?
No.
I saw this movement, so I was wondering. Right? Oh, your phone case, McKenna. While we wait, pause for station identification and a little bit of an ad. Today's review is brought to you by Clausen Pickles. When I eat pickles, and I do a lot, I always go for Clausen for that kosher crunch. Next page, yes. Yeah. From 6 to 9. Nice for you guys. For 3 to 6 for basic geometry. Most of basic geometry is juniors, which means they're exempt. So they're probably not going to be there. So you can show up early, see what happens. A lot of your review is the same as theirs. They just don't have the proofs. So show up early, great. Or show up from 6 to 9. Sorry your stuff is late.
And order a pizza.
Yes, and order pizza. Just kidding, you don't have to. But if you do, I get the box tops, right? That's the rule. That's the rule. I have negative $3 right now in my bank account to make till Friday, so I would love to get a free pizza.
That's illegal. You have to pay, what you call
Yeah,
it?
overdraft fees. Yeah, it sucks, man. Because I got student loans.
And they just suck them right out of your bank account.
You only have negative $3.
What happens if you just quit paying them?
Next. Name the angle. You love this one. Guess what? Probably not going to include this on the final. Will you need to know how to identify an angle? Yeah, because you're going to do that all the time. So let's go over it. MAP is map. That's one way to name it. Why does A have to be in the middle? Because it's the vertex. I could also call it PAM. Because it's A in the middle. I could also call it angle 5. You see that? Not very often, but sometimes you do. Right? Doesn't mean it's 5 degrees. It means it's angle number 5. And then you could also call it angle A, which is by the vertex. The reason I don't like calling it angle A is because if there was another ray sticking out of here, you wouldn't know which one was angle A. It could be this one. It could be that one. What's up, Grant? It could also be this guy, right? So that's ambiguous, but you can call it that. You guys know what ambiguous means?
Yeah.
Ambiguous means unsure.
I don't like big words.
So you don't know what it means because it means you aren't sure, right? Name the rays. Hi, Ray. Here's a ray. AM. A going to M. Direction matters. A going to P. Direction matters. Oh, yikes. You guys having problems?
Huh?
She left you.
Oh, no.
Okay, good.
Oh, so did mine.
So did my dad.
That's the one joke he has.
Buy you a pickle and do an ASMR.
All right, next. Definitions. That was embarrassing. Definitions. If angle A is acute, then that means it must be between 0 and 90, non-inclusive, right? Can't be 0, can't be 90. But it's between them. So you can write it however you want. I write it with math. Less than signs, right? You could write it. An acute angle is anything between 0 and 90, not including 0 and 90, if you want. I don't care. If it's exactly 90, it's a right angle. If it's between 90 and 180, it's obtuse. If it's exactly 180, it's a straight angle. If it's between 180 and 360, that's a big range. It's a reflex angle. Remember, that's the hyperextension one, right? If it's exactly 360, it's a revolution, right? The Bernie Sanders angle. A and B put together, if there's two angles that add up to 90, then we call them complementary. And if they add up to 180, we call them supplementary. Questions on that? Want to take a picture or no?
So if we're all created equal,
Are we doing this or no? Awesome. Turning the page. Next one. Don't look at this. Ah, God. Awful. I made a mistake on that one. I wrote it down wrong because I recycled the problem. This review guide made the correction. Also, I have multiple review guides from having done this 3 different times yesterday. So if you want one of those, I got them for you. Oh, man. Is the good one gone? Yo, what's up? It what? You can, but you can't keep it.
this is his first time
You wanna
ever
see it?
seeing snow.
Why does this not have a thing?
This is the first time Mr. Max ever seen snow.
That's not accurate. I've seen much snow. Some of my friends were addicted to snow. All right.
Smoking some white girl?
Angel dust.
Snorting some white girl with everybody?
No, it's not what I'm saying. I'm saying that I used to be a musician and I knew people. Drugs are not good, kids. Don't do them. Not even once. Okay?
Are you telling us from experience?
No, I'm not.
You can have a little bit of salami, so why not?
There's
a little
drugs
bit?
and then there's...
Why is this not working? That is
And then there's
correct.
hardcore drugs, like,
Why am I not
Listen,
finding this
cats
right
can
now?
have a little bit of salami, we can have a little bit.
Is there a review guide, a big review packet back there with all the answers on it somewhere?
There's hardcore drugs like catnip and ibuprofen and Tylenol.
Catnip, ibuprofen, Tylenol, Flintstone gummies, man. Oh my
Oh,
god.
God.
Oh my God.
Bro, them Flintstone gummies will mess you up.
Justice, please stop. Thank you.
Makes your nose longer.
I don't believe this. Why is this not here?
I might have took yours from last night. Is that what you're looking for?
No, I had it this morning.
That is hilarious.
That got super like.
I think someone took my review guide.
Have you ever snored?
All right, shut up and listen. Here's the idea. First up, this right here is CAF. That's what they gave you. This is 95, okay? That was the old one. This is the new one. I changed the problem. I was recycling it. Then it's, instead of writing BAD, don't write that. Write that BAF. We're trying to prove that BAF equals 135 degrees, okay?
I know what BAF equals.
So I'm going to walk you through the idea. I'm not going to write it. Here's what I do, okay? I'm going to say that these three angles all add up to this angle right here, CAF. That's my segment addition or angle addition postulate, right? These three angles add up to the big angle. Then I'm going to substitute their values. So I write 35 plus 2x plus 40 equals 95. Then I solve for x, and I get x is 10.
Excuse me.
Then I write that these four angles add up to the big angle, and I substitute their values. 4x plus 35 plus 2x plus 40 equals BAF, which I don't know yet. Then I plug in 10 by substitution, and I add 40, 35, 20, and 40 together, and I get 135. Proof done. You're going to need substitution and angle addition postulate. How do you feel about those concepts?
I don't feel good on the, I don't feel good on the proof.
Angle addition postulate
Just a quick review.
means that you can add up these three angles to make the big angle. You can add up these four angles to make the big angle. Okay? Substitution means switching stuff out, right? So plugging in for x, switching out CAD for 35.
Are we going to be able to use vertical angles here?
Oh yes, for some of them. Hi. That's okay. Did I do something wrong earlier, or is everything okay?
It's fine. I'm just kind of like listening.
Gotcha. Wasn't my fault though. Anything I can do? Talk to me later. All right.
Exempted from the exam.
Next one. Look at this star. It's waving at you, just like you. You're a star and malformed. What?
Star, distant and not.
Is it concave or convex? Here's how you tell. If you look at the internal angles, we have a lot of them. Here's one, there's one, there's one, there's one. At the internal angles, the inside angles, if there's at least one that's more than 180 degrees, meaning that it's a reflex angle, then it is concave, right? Concave caves in. So if you see greater than 180 for one of the internal angles, concave. This one has 5 different ones that are greater than 180, right? So very concave. It has 10 sides, which means it's a decagon. We call it a decagon because dec means 10, which is why December is the 10th month of the year.
Roman calendar.
Yes, Roman calendar, December was the 10th month originally, now it's the 12th month. October used to be the 8th, that made sense. September was the 7th, that made sense. August, they called it Augustus, right? Because Augustus Caesar, right? They called it August because of that. July was Julius Caesar, right? But then we went and screwed it up and made January the first month.
That's why there's more.
Why do we call February February? I don't know. I have no idea. So, this is a decagon because it has 10 sides, just like December is the 10th month of the year. This side right here, to find its length, we can't count it like we can for this one, right? This one's easy to count. You just count 8 because it's horizontal. This one's at an angle, so we have to figure it out using Pythag. Notice if I make a right triangle, it's 4 here and 3 there, which means 4 squared, which is 16, 3 squared, which is 9, added together and rooted. That's 25 rooted, which is 5. This one's also a 4 by 3, so is this. So they're all 5 right there and there. I mark them with marks to say that they're congruent. Notice that I marked this one with 3 and that one with 3 tally marks, so I'm going to mark this one with 3 tally marks to show it goes with it. This one's root 20 because it's 2 and 4. 4 is 16, 2 is 4. We add them up, root them, it's 20. 20 rooted is just root 20. And it matches this. Yes, you will. Root 53 for this one because it's 2 squared and 7 squared. 7 squared is 49, 2 squared is 4, 49 and 4 makes 53. We root it. Root 53. These are all root 53s because they're 2 by 7s. And then there's a root 34 all by himself, just like you will be the rest of your life. 5 here and 3 there. So we have 25 and 9, which makes 34, and we root it. Now we're going to add them all up. Justice, give it back. Making way too much noise, and it's way too much distraction for you. Thank you. When I add them all up, here's what I get. 5 plus 8 plus 5 plus 5 gets me 23. I have 3 root 53s, so I write 3 root 53. I have 2 root 20, so I write 2 root 20. I have 1 root 34 all alone, so I just write 1 root 34. Could you plug that in a calculator and get an answer? Sure you could, but it would be a decimal that goes on forever, and you'd have to round, which means your answer would be less right than mine, and it would take more effort. So I ask you why. No. Whenever you use a calculator, it guaranteed takes longer than it would to not. Almost every time. For any of my questions. Because my questions are meant to be solved without a calculator. If you plug that in a calculator, it takes more time than just writing it.
I need assistance at the bottom.
So check it out. 5, 8, 5, and 5 is 23. I have 2 root 20, so it's 2 times root 20. I have 3 root 53, so I write 3 times root 53. And then I have 1 root 34, so it's just root 34. I don't plug that into a calculator. I don't find out anything. I just leave it like that. That's an exact answer. If you plug it into a calculator, you have to round because it's a decimal that goes on forever. Why do more work to get a less right answer? I ask you. I ask you. Next page. No. Concave, because it has 2 angles that are internal that are greater than 180. All it takes is 1. This is a 7gon or a septagon. This one doesn't really have a nice name, so I probably won't give it to you on the test, right? You have to know the real names for these. Wait, is this 7? 1, 2, 3, 4, 5, 6, 7, 8. It's 8. I knew it.
Why does that look like Mr. Graff is calling?
Octagon. Imagine being a person that makes a makes the ring for like the UFC fighters, and like you got to make an octagon, man. Make us an octagon, and you make this for them, right?
I'd hate to get in that.
They said octagon, right?
That's true. They could technically do that.
They could, couldn't they? It'd be fun to see like Conor McGregor take his punk butt over here and hide in the corner, right?
They'd have to say what? Convex? Octagon?
They'd have to say a regular octagon. All sides the same, all angles the
Says
same.
that in the
Probably does. Next one, hexagon, because it has 6 sides. Is it concave? Yes, it is. We have 1 angle that's greater than 180. Next one, is it concave? Yes, it is. We have 2 angles that are greater than 180. We call it a dodecagon because do means dos and dec means 10. Everybody knows about Dodecember, right? The 12th month of the year.
Sure.
Easy proof time. Negative 3x minus 7 equals 14. Prove that x is negative 7. Well, I add 7 by the addition property. Then I divide by negative 3 by the division property, and now I'm done. I know. This one for fun, class. What properties would I use to solve this one?
Division.
I would use what?
Division.
Nope.
3.
What properties would I use? What's up, Corey?
Addition postulate.
Addition. I'd use the addition property of equality, and I'd use what? Multiplication property of equality to solve. Done. X would be negative 32. 21. A, B, and C are collinear. I swear to God. What does collinear mean?
In a line.
They're all on the same line. Very good. So A, B, and C are all on the same line, so I drew that. In that order. Don't be like, I want to be creative and put C in the middle. I see that way too much. Why would you do that? It doesn't make sense that way. It says AC is 6, so AC should be the whole thing, right? So here we are. We know that these 2 segments should add up to 6 by the segment addition postulate, so I wrote that. AB plus BC should equal the whole thing. Am I done? No, but I stopped there because ain't nobody got time for that. Then I plug stuff in by substitution, right? So I'd put negative x plus 2 here, negative 3x minus 4 there, and 6 here. Then I'd solve, find out x is some number. Turns out it's going to be negative 2. And then when I plug it back in for BC by substitution, I get BC as 2.
Can I go to the bathroom?
You what? Very, very loosely. Very loosely. Like as loose as possible. What? Yes, you may. McKenna, enough.
It's not like your Chrome tried broken. Let's see if he broke his Chrome.
Next one. Here we go.
Let's see if you broke it anymore.
Shh. Here's the setup. Oh, God, that's not good.
What did you do?
All right, put it away. We have no time.
I can't close it.
Justice, don't close it. Just put it on his
I can't
desk.
close it. Yeah, use your ability to fix that.
Yep, he does. All right, so the setup here. Oh, my God, no one cares. No one cares. Next part. ABC. It's an angle. It says D is in the interior of it, so I put D in the middle of it, right, the inside. It says that ABC is 165, so I wrote that it's 165. It says ABD is this stuff, so I wrote that. It says it's this stuff for CBD, so I wrote that. Here's how I'm going to solve this. ABD plus DBC gets me the whole thing, ABC. That's angle addition postulate. Then I'm going to substitute their values. I'm going to put that in for ABD, I'm going to put that in for CBD, and I'm going to put that in for ABC. Then I'm going to solve for x. Turns out x is 30. Then I'm going to plug it back in by substitution, and I'm going to get that ABD is 55. Done. How do you feel about that idea? Shh. Hey, guys. I know because like something happened, we have to act like it's the most funny thing ever that's ever happened in the history of anything because we are high schoolers, and that's what you do because your lives are meaningless outside of that little bit of humor. But I need your focus now because you have a final to take in a couple days. Right? Facts, no printer.
Okay.
All right. Got him. All right, so here we are. Write down the given. 1, it's 3 points. 2, it kind of helps you get stuff done, right? So check out this diagram. It tells you JK and LM are the same, so I wrote them the same color. That's nice. Does it say anything about JL or KM? No. It just wants us to prove something about them. So we need to go find some information about JL and KM from the diagram. JL is this red segment right here.
Yeah.
KM is this orange segment right here.
Yeah.
So I write that JL is JK plus KL. Because it is, right? Look, JK plus KL, right? That makes up the red part. Notice that KM is just LM plus KL, so I write that. That's segment addition postulate. Oh my God. All right. Again, it's like mildly funny at best. Let's be honest.
That's what hurts me when he says
Next. So, by segment addition postulate, those two make up the red, those two make up the orange. We good with that? Notice that JK and LM are the same color, meaning that they're interchangeable. So I'm going to write JL equals LM plus KL instead of JK plus KL. Totally valid. I did that by substitution.
Dude.
Schlaffer, I need you to put it away right now. Schlaffer, thank you.
Just fix that.
Great. So now we've got this. JL is LM plus KL. We good with that?
Dude, just
Come on, man. This is for you. This is for you. LM plus KL is JL. I switched out JK for LM. You with me? Awesome. Awesome. Well, this is the one that screwed up everybody in the quiz, so that's why I'm making sure we get it. Okay, great, 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 great. Fantastic. Don't have time. So, now notice that KM and JL are the exact same thing, right? And if they're the exact same thing, then they should equal each other, right? See how this equals LM plus KL? And that equals LM plus KL? Then they must equal each other. So I write that by substitution. They wanted red first, not orange first, so I switched them by symmetry property. If you don't switch them, it will be wrong. My advice to you is just write it correctly the first time. I switched it to show what you would do if you didn't. Okay? Symmetry property. How do we feel about that?
mildly okay.
Mildly okay. Again, what is JL? It's these two put together. What is KM? It's those two put together. Notice that when I switch out JK for LM, KM and JL equal the exact same thing, which means they must equal each other. Better? I'll take better.
Get there.
All right.
Get there.
Thank you, guys. All right, on to 26. This is another one that kind of screwed you guys up. Maybe it didn't. For you particularly. This is a bunch of garbage. So write down the given, and you'll actually see the answer pretty easily. We want to get blue and orange together. So here's the given. Here's blue, here's orange. So here's how I'm going to solve it. I'm going to say orange is the same thing as green, right? Which means orange is the same thing as...
Oh, wait, you could just use
Orange is the same thing as green. So orange is going to be the same thing as purple by substitution, right? So I'm going to write that. Then I'm going to say purple is the same thing as blue. So I'm going to switch out purple for blue by substitution. And now I've got what I want, just in the wrong order, so I flip it by symmetry. Is that what you're going to say?
Yeah.
Awesome. Rad. Glad you saw it. How do you feel?
Yeah, this one, that's...
Better? Again, if you write the given, it makes a lot of sense. If you try to just read it off of here, you're going to be in trouble, okay? Don't read it from here. Write down what they said. Do it in color. That's my advice on that one. 28. This one's kind of a tough one, but once you see it, it's not too bad. So here it is. Given all this stuff, I wrote it down. 1 and 2 are supplementary. Don't write that 1 and 2 add up to 180. They didn't say that. They just said it's supplementary, okay? We know what that means, but we're going to prove that, okay? 3 and 4 are supplementary. We also said 2 and 3 are the same thing. So here's what I'm going to do. First step, and I'm going to write out what that means. 1 and 2 add up to 180 by definition, right? Then I'm going to say 3 and 4 add up to 180 by definition. If they both equal the same thing, don't they equal each other? By subs. Then, because 3 and 2 are the same, I'm going to switch out 3 for 2. So when I subtract them, they go away, and I get 1 is 4. That's it. Dykeman, how do you feel?
Yeah, I get that. This one I actually kind of like.
I like this one too.
The hard one,
I like this one too.
showed-
It really makes a lot of sense. You know, if you see it. If you don't see it, you're kind of screwed, right? But let me help you see it. Questions on that idea? Feeling good? Okay. That's 28. 29 is complex, but here's the idea. I want to prove that 1 and 4 are the same, and 2 and 3 are the same. So first off, don't use vertical. I said you can't use them, right? Not allowed to, right? So here's what we're going to do. We're going to prove vertical angles theorem, essentially. We're going to say 1 and 2 are supplementary by LPT. 2 and 4 are supplementary by LPT, which means they both add up to 180, which means they equal each other. So 1 and 2 equals 2 and 4. Subtract angle 2 from both sides, 1 and 4 is the same. It's basically what we did on the last page. Then to prove that 2 and 3 are the same, I'm going to say that 2 and 4 are a linear pair, so they add up to 180. 3 and 4 are a linear pair, so they add up to 180.
It's a full circle, basically.
So this and this equal each other, which then means I can subtract angle 4 from both sides and get that these two equal each other. Smell what I'm stepping in. I'll go through it again.
Could you do it for the left side?
Yes, you could. Angle 1 and angle 2 are a linear pair. Angle 2 and angle 4 are a linear pair, which means they must equal each other. 1 and 2 should equal 2 and 4. When I subtract angle 2 from both sides, I get 1 equals 4. If I want to prove 2 and 3 are the same, I'm going to say 2 and 4 are a linear pair. 3 and 4 are a linear pair. Subtract the guy they share, and I get 2 and 3 left over. Feeling okay about that? Okay. This one, their definitions, I did not write them down. I'm just going to say them. Transversal, a line that cuts two other lines. Do the lines have to be parallel? No, it can be any two lines. When the lines are parallel, that's when the magic happens, right?
Yeah.
Corresponding angles is when two angles have the same relative position, like 1 and 5. They're both in the top left corner of their intersections. If the lines are parallel, then 1 and 5 will be congruent, right? Corresponding angles postulate. We'll say they're congruent. Same thing with 4 and 8, 2 and 6, 3 and 7. Same side interior angles. Well, same side means on the same side of the transversal, like 1, 2, 5, and 6. Interior means they're on the inside. So 2 and 5 are same side interior. Same side exterior is same side, but they're on the exterior. So 1 and 6, 4 and 7. Okay? Alternate exterior angles means on the outside. Alternate means on opposite sides of the transversal. So 1 and 7, 4 and 6. Now you might say, well, 1 and 4 are on opposite sides of the transversal, and they're on the exterior. Why are they not alternate exterior angles? Because they're better represented by a linear pair. So 1 and 7, 4 and 6 are alternate exterior. Same side exterior is going to be on the same side and on the exterior. So 1 and 6, 4 and 7. Alternate interior angles, I think I did same side exterior twice. Alternate interior angles are going to be on the interior, opposite sides of the transversal, like 2 and 8, 3 and 5. Why are 5 and 8 not alternate interior? They're on opposite sides and they're in the interior.
They share a line.
They are more accurately described as a linear pair. That's why. Okay, so 2 and 8, 3 and 5. Those are alternate interior. Questions on that?
No, that's simple to me.
Okay, if you know it, you know it. If you don't, you don't. If you don't know it, please talk to me because I can teach it, I promise. I can catch you up. 31. How do you feel about this proof?
Oh, these are what I'd actually get good on.
Prove angle 2 is congruent to angle 7. So 2 and 3 by vertical, 3 and 7 by cap. It's all good. And then 2 will be 7 by substitution. Prove 4 and 7 are supplementary. The first thing I like to do is get a statement with supplementary in it. So I'm going to say that 4 and 3 are supplementary by linear pair. And then I'm going to say 3 and 7 are the same by cap. So I can switch out 7 for 3 and say 7 and 4 are a linear pair, meaning they are supplementary. Right? Make sure you write the given. L and M are parallel. Without that, we can't do any of the cap stuff, right? Awesome.
You still really need that argument when you
If you know what it is, you've had time to actually digest it, you did learn it the first time. This is not like all your other final reviews where you never really learned it the first time. And you have to learn it all now or rememorize it, right? If you learned it the first time, now it's just really reviewing it, reminding yourself. You understand this stuff. And if you don't, come talk to me. We can fix it, I promise. This one. This diagram, they give you that these two are 50 and that this is 145. So when this asks about these two angles, well, they're vertical, so they're both 50. This part right here is 145, which means if that's 50 and that's 50, that's 45, because it makes up 145 total. And then I know that this part right here should be the same as this part down here. How do I know how much this is? Well, because this is a linear pair. And if that's 50, that's 130, which means this whole thing right here should be up to 130. So that's 50 and that's 45, that's 35. This right here is vertical with this. Okay? This is a linear pair. So if that's 50, that's 130, which means this whole thing's 130. And if that whole thing's 130, and that's 50 and that's 45, what's left over is 35. Okay? We got some vertical angles going on here, linear pair, et cetera, et cetera. How do you feel about that idea? Okay. Page 24. All the lines are parallel, so we write that down. Given P and Q, M and N. I want to prove that 3 is 15, so 3 and 7 by cap, 7 and 15 by cap, 3 and 15 by subs.
Easy. Wow.
The bottom one, prove that angle 10 is supplementary to 7. So I'm going to say that angle 10 and angle 11 are supplementary. And then I'm going to say, by LPT. And then I'm going to say that 11 is 15 by cap, 15 is 7 by cap, so 7 and 11 can be switched out by subs, which means 10 and 7 are supplementary. How do you feel about that? Have I completely lost you? Have you zoned out? I'm doing this for you.
You lost me after the first Jurassic Park movie.
Next one. Notice that 10 and 14 won't be congruent because P and Q are not parallel. We don't have two parallels cut by a transversal. But if we look here, we have two parallels cut by a transversal, so 10 and 2 will be the same. Same thing down here. 6 and 14 will be the same because two parallels cut by a transversal. They give us that this is 115 and this is 85. I can get 5 by vertical. I can get 6 by linear pair. I can get 11 by linear pair. I can get 12 by vertical. I can get 2 by cap. I can get 14 by cap. How do you feel?
Perfect.
Okay. Buckle up. This is the big one. I've got your attention? Wonderful. Check it out. Here's the idea. I'm trying to prove that angle 6 is 160. So I'm going to say angle 1 is congruent to angle 5 by cap. 5 and 13 by cap. That means by substitution, angle 13 must be 2y plus 8. I know 13 and 14 are a linear pair. I'm sorry, they're supplementary by linear pair theorem, right? Which means that and that should add up to 180 by substitution. So 2y plus 8 plus 30y minus 20 should equal 180. I solve for y. It's 6. I plug that back in by subs. I find out 14 is 160, and I do cap to get 6 is 160. We made it to page 26. Not bad, guys. Your review is from 6 to 9 tonight. You can show up early for basic geometry if you want. It's a lot of the same stuff.
A lot of people won't show up in the basketball game cheap.
Okay, well, whatever. Be here or don't. I'm going to be here anyway.
It's girls basketball.
Do what you got to do.
Are you here tomorrow morning?
I am here tomorrow morning. I'll be here at 7:30 tomorrow morning, if not earlier.
Show up at 7.
You can show up at 7. If you need to finish your test from Friday, you can do that in the morning or after school or during homeroom.
So can I come in the morning and...
Yes. Yes. That's fine. I don't care. That's fine. Right. Show up or don't. Leave early.
Don't touch your
Yeah, that's
stuff.
fine. That's fine. Make sure you have your portfolios to me before the beginning of next hour, or before class tomorrow. We're going to talk about those tomorrow. Make sure it's something you're proud to turn in.
I hate when people do that. You say honestly or